CS1010X, Lecture 5, Debugging and More. Humans make mistakes. You are only human, therefore you will make mistakes. Well, actually, very few people can write program and run with correct intent in the very first attempt. Most of us rely on debugging to get close to what we wanted. To date, you should have written some amount of codes to reach here, otherwise you ought to work harder, or still there is likely the myth that what is a good way to do programming. We usually just code and then debug. Hope that this lecture is not too late to help us a little bit to do the right thing. Let's get through some low-class errors before we move on to the proper debugging tips. For these errors, we must be able to recognize immediately and get rid of already. For example, we omitted return statement as in here. Define a square function as x star x, a missing return here. Incompatible types, x is 5, square is a function, and yet we try to add a values with a function. Incorrect number of arguments, square as defined is a function with one argument, but there are two here. Syntax error, define a process x, forgotten the colon, a do stuff, more stuff. But the do stuff here and more stuff, they are of a different indentation. Arithmetic error, x equal to 3, y equal to 0, x divided by 0, this is not allowed. Undeclared variables, x is 2, x plus k, but k is not found before. Infinite loop, define factorial n, nothing is wrong here, but when this is being called by factorial 2.1, then n can never get to 0 and the program will never stop. Factorial minus 1, same situation, n will never be equal to 0 and therefore it never stops. Define factorial iterative, there's nothing wrong, but again, factorial iterative minus 1, n equal to minus 1, this whole thing will never stop. Numerical imprecision. Foo is a function with a loop here relying on counter to reach n to stop. So counter started with 0 is incremented with 0.1. By right, when 5 is passed in, counter after 50 rounds should reach 5 with increment of 0.1 each time. But because of numerical imprecisions, the counter never exactly equal to n. You can try this yourself. Logic error, Fibonacci n is actually Fibonacci n minus 1 plus Fibonacci n minus 2. But there is a typo here, both are n minus 1. Wrong understanding of syntax or routine. K equal to 10 divided by 4, the answer is not 2, which is the case in other programming languages, but not in Python. We're done with all these low-class errors. We move on to more proper stuff. In doing programming properly, it should not be that I just code and debug and repeat this cycle. It should be that you have a proper environment set up for ease of experimentation. A simple tip is to set up a good font size, color for your text to make it comfortable to your eyes. Because we are new to Python, we may need to experiment with features first to know what are possibly useful to our problems on hand. Then we can go on to next plan on how to solve the problem. Planning is to work out a way to achieve with a big picture, gradually broken down into smaller pictures and so on. Wishful thinking about the existence of smaller pictures is adopted here. This is also a top-down design process. Then do the actual coding and debugging first for each smallest function. Debug it completely till you are confident that it is correct. Then combine a few into bigger function and so on. The bigger functions again needs to go through debugging till you are confident that it is correct for use to combine into even bigger function. This is repeated until we can do integration tests for all functions coming together. What is debugging? Debugging is to remove errors or bugs from a program. After debugging, the program is not necessarily error-free. It just means that whenever errors remains are harder to find. And this is especially true for large applications. You would have noticed too that we now and then need to patch up our Windows system, which is a large application, to remove bugs and errors too. For our purpose, debugging is actually to understand what your program does, verify with what your real intention may be on the following two aspects. 1. Flow of execution, as there are all kinds of looping. 2. Values change as they are evolving. And we are doing this with a small number of samples of small sizes that human can comprehend. Debugging often takes up more time than coding, so it is worthwhile to invest in making debugging less costly. Here are a few ways to do it. Invest in setting up a good programming environment. Invest in planning the intended solutions. Invest in learning about debugging tools and techniques. Invest in writing extra codes to assist in the debugging. Invest in testing individual functions. Invest in good programming practice. Programming environment. Besides setting up your IDLE with good font size and color, our screen space is usually large enough to put 2 or more windows. So it is good practice, in my opinion, to have a code window and a shell window side by side. Then you can experiment with codes by typing into the code window and then run with Fi or cut and paste the code from the code window to the shell window. This can save you lots of time in your repeating experimentations. Planning. We know that no plan is a plan to fail. This is usually how we plan to complete a program. It is incremental development. There are 2 parts to this. We need to write out the various functions and to use some data structures for support to the functions. We try as much as possible each function should perform one task. Such a function is easy to understand and easy to be tested. You have to pick the correct data structure for the tasks. A correct choice of data structure can ease the development of the function needed. Computer hardly makes mistakes. It does what you have told it to do, even though what you have told it is not what you actually wanted. There are tools around to help us realize our mistakes. By now, you should have done debugging exercises 1 and 2 and possibly 3. In debugging exercise 1, you learn about tracing of your program with print statements. And in debugging exercise 2, you experiment with the debugging mode in IDLE to understand the flow and to get to see the values of your variables. And in debugging exercise 3, we use Python Tutor to see the flow of a program and have a visual of your variable values. When you're doing debugging, you think like a detective, that where could go wrong. You look for clues from error messages and values of variables that you found. You try to eliminate those impossible places where error cannot be the case and focus on those that are more likely. You run the program again with different inputs to see whether the same error occurred again, and be sure if your program involves random input part, you should fix it so that your program behaves the same to hopefully repeat the error for investigation. Besides the idle debugging mode and the use of Python Tutor to view the values of variables, we often use the most primitive way of printing out values to understand what is going on. Here is an example. We have a function, debug print, that will print 3 variables if the debug printing flag is set to true. So when we want to use it, we set it to true, and then when we call it inside our function, debug print counter, n, result, we are trying to print out the values of these 3 variables while the program going through the while loop. Here's another example. Define Fibonacci and debug print n, now, because we have only one value to inspect, so the other 2 we set to null. And when this program is running, we will see the progressions of this value n. When we are done with the debugging, that we no longer need it, we can set the flag to false. And when this program is running again, this statement is no longer of any effect. Allow us to sum up some of the good practices here again. Use a debugger to trace a function from prompt areas backwards and to display variable values. When a program has many if conditions, beware that those cases lying on boundary need some special attention to be sure of their correctness. Invest in writing extra functions, extra meaning that they are not needed to achieve the goal of your program. This is to help us to do verification automatically. You can use some if condition to ascertain certain value for the calculations. To print out values of variables so that we can at one glance look through all the values to be sure where could be the problematic area. Test function one by one, do practice incremental development, and do testing systematically to at least go through some boundary cases and some non-boundary cases. Avoid unnecessary debugging with good programming practice. Use meaningful variables and function names for ease of understanding by yourself or other who helps in your debugging. Provide good commands to ease understanding. State assumption on usage of function or routines. Each function should do one task rather than mixing with many other tasks. Good practices from object-oriented programming. It is worth noting that debugging effort can be inversely proportional to good discipline in your programming. To sum up, debugging often takes up more time than coding. So invest where applicable to cut short the time. It is more an art than a science. You have to play detective. The more you practice, the better you are.